This is Algebra 2. It asks, from these given zeros, write a polynomial in standard form of the least degree with integral coefficients. Integral coefficients mean every coefficient is an integer. So I'm going to do this one first. It says 1 multiplicity of 2, 0 multiplicity of 2. When there's a multiplicity of 2, it means that 0 happens twice. And when the multiplicity is an odd number, it goes through the x-axis. When it's an even number, it bounces off the x-axis. And then the bigger it is, the more it flattens out. So if it's 3, it kind of has a little bend in it. If it's 4, it's going to be a little bit flattened there. If it's like 12, it's going to be real flat where it touches. Here, let me try to draw it real flat. Something like that, where it should touch right there. Something like that, but still bounces off. Oops, what did I do there? Somehow, there it is. Somehow I got rid of everything. I didn't mean to get rid of everything. But anyway, so that's what multiplicity means. It means the root happens twice. That means the factor appears twice. And it's going to affect that least, what's the lowest degree I can have. So let me do this one first. It says it has 1 multiplicity 2. So x equals 1 twice, and 0 multiplicity, x equals 0. When x equals 1, if I subtract 1 from both sides, I get x minus 1. But it says multiplicity 2, so I need a second x minus 1. And then this one is just x. Oh, multiplicity 2. So it's x times x, which is x squared, but I'll write them both out. So I'm going to do this. X times x is x squared. X minus 1 times x minus 1 is x squared minus 2x plus 1, all times x squared. And that's going to be x to the 4th minus 2x cubed plus x squared. And you can plug that into a calculator to make sure that it has 1 multiplicity 2, 0 multiplicity 2. Let me do that. If I find Desmos, I'm going to do x to the 4th minus 2x's cubed plus x's squared. And I'm going to have to zoom way in here. You can see it bounces off twice. It bounces off at x equals 0, bounces off at x equals 1. So that's good. Okay, that's that one. Now, I got negative 3 and 2 square root of 2. I'll make a little bit more room over here. And let me pull this one so that I can get some room. And it's the same thing. I want a polynomial of least degree that has these zeros. In standard form, I want to write it, which means the powers of x go down from left to right. And I want integral coefficients. In other words, they're all integers. Now, anytime I have a square root or an I need the conjugate as well. So if it's plus 2 square root of 2, it's also minus 2 square root of 2. If it's plus I, it's also minus I. So I'm just going to write x equals negative 3, x equals 2 square root of 2, x equals minus 2 square root of 2. And then I add 3 to both sides, so the factor is x plus 3 equals 0, x minus 2 square root of 2, and x plus 2 square root of 2. I just added 2 square root of 2. Always do the i's or the square root ones first because the middle terms are going to drop out. X times x is x squared, minus 2 square root of 2x plus 2 square root of 2x. Those just cancel. Negative 2 square root of 2 times 2 square root of 2 is negative 4 times square root of 2 times square root of 2, which is 2. Negative 4 times 2 is minus 8. And then x plus 3. Now finish this. I get x cubed, x times x squared, x times negative 8 is minus 8x, plus 3x squared minus 24. And I'll write that in standard form with the powers going down. So this is plus 3x squared minus 8x minus 24. And I'll show this one on Desmos. X cubed plus 3x squared minus 8x minus 24. And let me look at it. I can see here's my negative 3. That's, I I think that's 2 square root of 2 or negative 2 square root of 2. Yep, 2.828, so it's going to be negative 2.82843, etc. And then positive 2.82843, etc. So there's it. There it is. All the roots that I needed. All right, what's the next one? Where's the next one? Negative 5, 1, and 4. Negative 5, 1, and 4. It's the next one I want to do. Negative 5, 1, and 4. So x equals negative 5, x equals 1, x equals 4. So I add 5, x plus 5 is the factor, x subtract 1 minus 1 is the factor equals 0, and then x minus 4. So those are the factors. And now I'll just multiply these two together and then multiply by x plus 5, x squared minus x minus 4x is minus 5x. Negative 1 times negative 4 is plus 4. And then I've got times x plus 5. I just wanted to see were any of those multiplicity 2. They were not. So x times x squared is x cubed minus 5x times x is minus 5x squared plus 4x. And then plus 5x squared minus 25x plus 20. So I get x cubed minus 19x plus 20. And let me check it. X cubed minus 19x plus 20. And I should get, what were they again? The zeros I get should be negative 5, 1, and 4. There's negative. What have I done wrong here? Something has gone wrong. You've done something wrong. Okay, let me double check it again. X equals negative 5. X is 1 and x is 4. This is x squared minus 1x minus 5x plus 4. And if I multiply that x by 5, I get x cubed minus 5x squared plus 4x plus 5x squared minus 25x plus 20. I get x cubed. Oh, that's not minus 19. How come you didn't correct me? Minus 21x plus 20. Negative 25 plus 4 is negative 21. Why didn't you correct me on that? Negative 21x. Now I've got negative 5, I've got 1, and I've got 4. All right, that one worked. I made the mistake purposely just so I could show you how to correct it. Do you believe me? I don't even believe myself. All right, 1/3 and 2i. And just like with the square root, if one of the roots is 2i, then there has to be a negative 2i. So I've got 1/3 2i and negative 2i. They always come in conjugate pairs if it's a square root or an I. So I get x equals 1/3, x equals 2i, x equals minus 2i. Now when I graph this, I'm probably not going to be able to see the zeros at 2i and negative 2i because those aren't real. They're not going to be where they cross the x-axis, and sometimes it can be a very subtle dip in the graph. So I'm going to subtract 1/3 from both sides, x minus 1/3. I'll make that a little simpler in a second. X minus 2i, I'm subtracting 2i from both sides, equals 0. And then x plus 2i. Now this one, I'm not going to leave it as x minus 1/3. So I'm going to have to be multiplying everything by a fraction. Let me make them a little bit more room. So I'm going to put that 3 by the x. I'm going to put 3x minus 1. Take the denominator and put it by the x. And then again, just like with the square root, this one, the middle terms are going to just cancel each other out. So I just have to do first times first, last times last. X times x, x squared. Negative 2i times 2i is negative 2 times 2 is negative 4. I times I is I squared, which is negative 1. Negative negative 4 is plus 4. And then I will multiply this. 3x cubed plus 12x minus x squared minus 4. And I will get 3x cubed minus x squared plus 12x minus 4. And let me write that one in. 3x cubed minus x squared plus 12x minus 4. And you'll see there's the 0 at 1/3, but where are those plus and minus 2i? There's just going to be a little, I see a little subtle dip in this thing, but I'm not really going to be able to make it out exactly. But anyway, so that's how to do it. I just made polynomials in standard form of the least degree with integral coefficients, integers, and I used the given zeros to do that.